Now, what other kinds of problems can we solve with calculus? A lot of times in this course, we've had to figure out when a function is equal to 0. And that's all well and good when we have a simple polynomial, a linear polynomial, very easy. A quadratic, we have a formula for that. A cubic, okay, there is a cubic formula, but we don't teach it in schools these days. So I hope that 0 is a factor, and then I can do something clever. Maybe a degree 4 polynomial. There is, in fact, a formula for solving degree 4 polynomials. It is multiple pages long. So if you want a laugh, look up the quartic formula on Wikipedia, and then come back and tell me how much you do or do not want to memorize it. But I'll tell you for free, there is no formula that solves all degree 5 polynomials or any degree higher than that. And more to the point, most of the functions that I'm interested in day to day are not polynomials. So how can I find the root of a function which is not a polynomial? Or at least, how can I get close? One of the key things that we've been building up in calculus is this idea that I don't necessarily have to find the exact answer. As long as I can get close, that'll be good enough. So here's an example of trying to solve a very high degree polynomial. Is it better to take one interest rate over another? Now, I'm not going to get into the specifics of this polynomial here, right? This model is just asking us, is it better to pay $375 a month for 5 years, or to just pay for this car directly? So the graph of this function would look kind of like this. And we can see that there should be a solution here. But we don't actually want to be magnifying this graph to find that solution every single time. We'd like some explicit set of instructions that we can just follow to find the approximate solution. Now, this method that we're going to talk about is called Newton's method. And the idea is that we are going to make a guess about where the solution should be. And then we are going to improve that guess.